Hi everyone, welcome back. Today we're doing merge two sorted lists. We're given the heads of two sorted linked lists, list 1 and list 2, and we have to merge the two lists in a one sorted linked list. The list should be made by splicing together the nodes of the first two lists. So what this means is we cannot create new nodes with the same copy of values. So we will return the head of the merged linked list after doing the merge. So for our viewers who are new to this data structure, linked lists are an iterable data structure where this iterable data structure consists of nodes. And as you can see on line 2 to line 5, these nodes are really objects that you define yourself. In this case, these nodes contain two attributes. The first attribute contains a value, and in this context of this question, each of these values represent an integer. For the next attribute, this points to it's a pointer to the next node. So in a sense, if you have a node and the next is pointing to another list node, then you can use .next to access the next node in line. So that's pretty much how we would iterate through linked lists, by calling .next on it. So for example, if we have a linked list 1 consisting of 1, 2, 4, and another linked list consisting of 1, 3, 4, we will return back a linked list with 6 elements: 1 from list 1, another 1 from list 2, 2 from list 1, 3 from list 2, 4 from list 1, and the final 4 from list 2 as well. For the second example, they are giving us good hints. List 1 and list 2 are empty, so in this case we will return an empty linked list, in other words none. And for the final example, if list 1 happens to be empty, then the answer is just list 2. So here's our strategy. As usual, I'll be copying over the test case, list 1 and list 2 in this case, as well as this test case. Okay, I'll just copy the other two test cases in a bit later. But the idea is, the first step is to check if list 1 or list 2 is empty. So if not list 1, so notice that list 1 is an optional of a list node. So let's say if list 1 is none, then we will just return list 2. It's okay even if list 2 is empty, because if list 2 is none, then we will just return none over here as well. Else if list 2 is none, then similarly we'll return list 1 over here. Else, in this case, this is where most of the logic will come to play. This is when both list 1 and list 2 are both non-empty. They are both containing a linked list. So in this case, what we can do is we can define we can check the value of list 1 and list 2, the values at these two linked lists over here, and we can compare the values of these two current nodes. And we will set the smaller of the current nodes to be the head of this new linked list. So let's call this merge head, and we'll be doing a quick check over here. If list 1.value is less than list 2.value, then we will set the merge head to be equals to list 1, and we will also advance list 1. So over here, we will also need 2 additional pointers to iterate list 1 and list 2, and also 1 additional pointer which we will define later for iterating through the merged linked list. So first, let's define list 1 pointer. This will be an optional of list node, and this will be equals to list 1, and similarly we'll have another pointer for list 2 as well, so equals to list 2. And if list 1 value is less than list 2 value, actually we can just use the pointers now. Since we have it, we will just set list 1 pointer to merge head, and we will advance the list 1 pointer in preparation for the next check. Else, in this case, then we will just set merge head to be equals to list 2 pointer, because in this case list 2 pointer is the smaller one, or is of equal value to list 1. Then we will arbitrarily set merge head to list 2 as well. So list 2 pointer equals to list 2 pointer.next. And at this point, we have the merge head. We can finally we can set this to a list node over here. So at this point on line 26, we can define the merge pointer now. So the merge pointer, which is a list node, would just be merge head. Actually, in this case, it's okay to just, actually no, this can still be potentially optional, so I'll leave that as it is. So the next step would be to consistently do the comparison between list1 and list2 pointer as long as they are both defined. So if they are both defined, then what we will do is, if list1 pointer val is less than list2 pointer val, then what we will do is we will similarly set merge pointer dot next to be equals to list1 pointer. And similarly, after we use list1 pointer and assign it to the merge pointer, we will advance the list1 pointer as well. So list1 pointer dot next. Else, we will also do the same but with list2 instead. So merge pointer dot next. Oh, of course, there's one thing that I missed out, which is to advance this merge pointer. So after we have set the merge pointer, we must also advance it so that the next in line would append to the next of this current node that we just added. So merge pointer dot next is equals to list2 pointer. Similarly, we will advance the merge pointer, and we will also advance the list2 pointer over here after we assign it to the current merge pointer. So everything looks great. Okay. So at this point on line 37, it is possible that either list1 or list2 is none. So if list1 pointer, in other words, list1 pointer still has elements and list2 pointer is empty, then what we will do is we will set merge pointer dot next to be equals to list1 pointer. Else, we will set merge pointer dot next. Actually, we can do else if list2 pointer. Then we just do merge pointer dot next equals to list2 pointer. And at this point, after all these iterations, we can finally return the merged head. And that's pretty much it. This is the logic responsible for splicing list1 and list2 together, as long as both linked lists are still, like the pointer in both linked lists is not none. And once that is none, we will just assign the remainder of the linked list to the end of the merged linked list. And that was quite a lot of details. So let's quickly trace that out with a simple test case, list1 and list2. So list1 and list2 is one of the harder test cases. This logic would probably work. Actually, it does work for the simpler test case where list1 or list2 is empty. So that is fine. We can skip that tracing for that. So now let's set list1 pointer to be equals to list1 pointer to be equals to list1. So in this case, this is pointing at 1 over here. And list2 pointer will be pointing to list2, which is the first element in list2. So currently this will be false. List1 pointer is not less than list2, so we will hit this branch over here. So we will set merge head to be equals to list2 pointer. So I will just append list1 pointer over here, and we will advance list2 pointer. This will now be pointing at 3. Now we will continue. Merged pointer will now be pointing at 1, and we will continue. So at this point, list1 and list2 pointer, this is true and true. List1 and list2 consist of numbers. There's still elements to be iterated in list1 and list2. So we continue. At this point, merge pointer dot next equals to list1 pointer. Is this true first? Is list1 less than list2? Yes, this is true. So we will hit line 30. Merge pointer dot next will be equals to list1 pointer. So what this means is, actually, you know what? Let's use merge pointer to trace the list instead. We will just set this to be 1. So over here, we're setting merge pointer not next to be equals to list1. So we will set this to 1, and this is done. And we accelerate this, so this now points at 1, the second one over here. And list1 pointer will now advance to the next element, which is 2. So we continue on the next loop. List1 and list2 are still defined. We are still here at the second item. So in this case, we hit line 29. This is true. 2 is indeed less than 3 over here. So we set merge pointer.next to be equals to 2 over here. And over here we advance the merge pointer, and we advance the list1 pointer as well. So list1 pointer will now be pointing at the final element in the first linked list. So we will continue. Now in this case, this is still true. Both list1 and list2 are still defined, so we continue. So over here, list1 is no longer less than list2 because 4 is not less than 3. So this is true over here. So we continue over here. So now the merge pointer is now going to point to, we're going to add 3 into the merged linked list instead, and we're going to advance the merge pointer. So now we're at 3. I will just do this for clearer tracing, and we advance list2 pointer as well. So now this points at 4. Now we are back at line 28. List1 and list2 are still true. They are both defined. So in this case, this is going to be false because 4 is not less than 4. So we hit line 34. So now we're going to set merge pointer to contain list2 pointer, and we're going to advance list2 pointer.next. This will be none. And now, once we come back, this is going to be false. So this will terminate. Line 28 will terminate, and we will continue on line 37. So in this case, list1 pointer is still defined. So this will turn out to be true. And merge pointer.next will be set to first pointer. So we will finally get this answer, and we will return the merge hit. So everything looks perfect. This looks like this is the answer. So let's quickly code this out again, and we also take the chance to summarize the strategy. So the first thing that we will do is check whether if list1, which is provided to us, happens to be none. And if that is none, then we will return list2. Similarly, if list2 is none, then we return list1 as well. Else, if list1 and list2 are both defined, then we will continue with the algorithm. The first thing that we did is define a pointer for both list1 and list2. So let's call this list1 pointer. This is an optional of a list node, and this is equals to list1. And we define another for list2 as well. So the next step afterwards is to check which of the two pointers are currently the smaller number. And if that is a smaller number, we will set the merge head to be that value. So what we will do is, if list1 pointer.value is less than list2 pointer.value, then what we'll do is we'll set merge head, which will be the head of the final linked list that we'll return. This will be set to list1 pointer. And what we will do is also advance the list1 pointer so that it's ready for the next iteration. So list1 pointer.next. So this looks great. Let's do else. In this case, if list2 is, if list1 is actually the larger value, then we will set merge head to be list2 instead. So at this point, we are finished setting the merge head, so we can start to define the merge pointer. The merge pointer will be an optional of a list node, and this will be set to the merge head. So at this point, we are ready to start iterating through both list1 and list2 until we reach either the end of list1 or list2. So while list1 pointer and list2 pointer, if they are both defined, then what we will do is we will be checking whether if list1 pointer is bigger or list1 pointer is smaller or list2 pointer is smaller. So if list1 pointer.value is less than list2 pointer.value, then similarly, in the same case, we will set merge pointer.next to be equals to list1 pointer, and we will advance the merge pointer. Similarly, we will advance the list1 pointer as well. So looks like this is good. Let's continue. Else, in this case, if list2 is a smaller number, then what we will do is merge pointer not next will be assigned to list2 instead. Merge pointer will be advanced as usual, and we will also set list2 pointer equals to list2 pointer.next. So we are advancing list2 in this case. By the end of this whole while loop over here, either list1 or list2 will be empty. So what we'll do is, if list1 pointer happens to be the final linked list standing, then we will set merge pointer.next to be equals to list1 pointer. And else if list2 pointer is the one that is the last linked list standing instead, then we will set merge pointer to list2 pointer instead. And at this point, we are ready to return back the merged head, and we got our final merged linked list. So this looks good. Let's delete all of this. And let's do one final trace to ensure that we didn't make any syntactical error. List1 is none, list2 is none, looks great. If list1 is empty, return list2. Otherwise, if list2 is empty, return list1. We define 2 pointers and we assign the merge head to the smaller of the 2 pointers. So this looks great. This looks great. We assign the merge pointer to the head so that we can start the iteration and splicing the merged list together. So while list1 and list2 pointers exist, we will set the merge pointer.next to the smaller of the linked list nodes among the 2 linked lists. So once done, we will advance the merge pointer in preparation, and we will advance the list1 pointer as well. Similarly, if list2 is the one that is the smaller one instead, then we will do that for that as well. And once we have done the splicing, we'll be left with either one of the linked list standing. So we will just put the linked list that is still present to the back of the merge pointer, and we are done. Looks like everything is good. Let's run this against some test cases. This passes, and let's submit this. Okay, and that's the answer. Let's go through the time and space complexity. For the time complexity, in this case, notice that we have to go through one whole linear iteration. So if we let n be the length of list1 and m be the length of list2, in this case, this while loop will be iterating through on plus om, because actually we will iterate on or om, whichever is smaller. So om or om, whichever is smaller. So in this case, if the first list consists of 10 elements and the second list consists of 20 elements, actually that's not guaranteed. Is it? That's not guaranteed. Because it might end up that the longer list consists of all the smaller numbers, and list 2 gets exhausted first. So whichever gets cleared first. So okay, and afterwards this step over here is going to be an O1 operation, because we're just going to append the final bits of the linked list to the back of the merged list. So there's no iteration, no linear iteration from here anymore. So it's on or om pretty much. So it's either on or om, whichever contains the smaller numbers. So this looks great. Step first. And for the space complexity, in this case we splice the nodes together. So we are just reusing the same list nodes that was in list 1 and list 2 to assign to reconstruct the linked list. So in this case, the space complexity is just O1, because we do not recreate a copy. We're just reusing the same nodes that existed in list 1 and list 2. And we just use pointer variables that doesn't scale in memory usage with the size of list 1 or list 2. So the space complexity here is O1. So yep, that's pretty much it for this question. So if you like this, please give us a like and subscribe, and we will see you in the next video.